So today we will cover horizontal pod autoscaler. Okay, that is a service available in Kubernetes. So when we configuring Kubernetes, we need to scale up our resources like scaling our pod container. So inside Kubernetes, we have to create a resources. That name is horizontal pod scaling, auto scaling. So it will scale up our resources as per our requirement. My screen is visible.
Yes.
HPA. We called as HPA. Full form is horizontal pod autoscaler. So coming to definition, like uh, horizontal pod autoscaler, it's a mechanism used to automatically scale the number of pods in deployment or replica set or stateful set based on observed CPU utilization or memory utilization or any other selected metrics inside Kubernetes. So the HPA ensure that number of running pods can adjust to match the demands on the application. So coming to features like automatic scaling, custom metrics, integration with the metric server, all these things are the features of horizontal pod auto scaling. Coming to automatic scaling, it will adjust the number of pods automatically based on metrics like CPU and memory usage within Kubernetes cluster. Then we can custom metrics can configure to use custom metrics provided by the application, like allowing more fine-tuned scaling decision like that. So we can use for that scenario. So how it like the like how the metrics collection happen within HPA, like metric, there is a server within the Kubernetes cluster that is called a metric server. So the metric server collects metrics from the nodes and pods. So based on the metrics, we will collect all the details of the running node and pod. So the metric server also monitoring CPU utilization and memory utilization within the nodes. So it will comparing with the desired state and the actual state, what we configured within the HPA configuration. For example, mm, like this is our uh, Kubernetes pod. See, this is our cluster. Okay, consider this is our cluster. So we have to deploy one application. So how we manually scaling within Kubernetes cluster? Anyone can say? Like I'm all manual scaling.
You add pods with the command line.
No, for example, like we need to deploy an application. So how we manual scaling our pod? I mean, after deployment or before deployment, no problem. Like coming to Kubernetes, we have two files, right? Like deployment YAML and one for the service for YAML to expose the service. Otherwise, we didn't use the service because if we didn't expose the service, I mean application file, we didn't create any service.yaml. Otherwise, we need two files. One is deployment.yaml, then service.yaml. We can use the service.yaml within this first file, like deployment file. We need to adjust the configuration within the file, or else we need to create two files. So this is deployment. And this is our service.yaml, right? So within the configuration of deployment.yaml, we can see the replica set, right? Replica.
Yes.
So we can adjust the replicas. The replica means replication of our running instances, right?
Yes. It's based on the number of pods we are deploying based
Yes.
on number of replicas which we are going to use it.
In coming to deployment YAML, that configuration file, we can see there is a option called a replica is equal to, we can mention, for example, it's one or two like that. So when we deploy, I mean, whenever we applying this deployment YAML, it will create two pod, or what are the desired state that we specified in the replicas, it will create after applying, right? I mean, number of pods, creating two pods. For example, our replicas is equal to 2. So it will create two pod and two container. Got it. And both having same application. So this is manual way, okay. So for example, we deployed this application successfully. So it will create two port and our application is running. So we need to add more number of ports, okay, like manual way. So what we will do, just open this YAML and edit the replicas like 3 or 4 like that as per the requirement. So only the Kubernetes upgrade what are the things we edited. So when I mean Kubernetes know that replicas, only the replicas is edited to 3 to 4 like that. So it will only I mean creating these things only. I mean after we redeploying, I mean reapplying this YAML file. So the Kubernetes know some configurations happen in our deployment YAML. So it will only, I mean, applying that configured part within our deployment.yaml file. See here, we can see the replicas is 2. This is one of the application deployment file. So quickly, meantime, I will create a Kubernetes cluster from scratch. Suvarna is new here, right?
I think she logged in and she logged out, I guess. Only we three are there.
Yes.
Myself, Amol and Tej.
So this is one of our lab. I mean, this was one of our lab, like how to create managed Kubernetes. Okay, managed Kubernetes in AWS account. Two-way we can deploy managed Kubernetes in AWS. Like one is go with the console way. Okay, like graphical way we can search here EKS and uh, like we can go with the dashboard like graphical way, or we can deploy EKS using command line. Okay, so this now I am going with the command line, so it's a easy process. So we need a local machine, like you can use your local laptop and configure. Do the necessary configuration. But now I can't use my local laptop. I have some privilege issues. So I am using one virtual machine from cloud. So this machine will be my local machine. Okay. So just I am connecting to my machine. Some prerequisites are there, like before configuring EKS or installing EKS. So what are things that like we need to install a like EKCTL. It's a command line tool. So we need to ensure that EKCTL is installed in this machine. Then kubectl is another command line tool for accessing or managing or interacting with the Kubernetes cluster. So it's another command line tool. So these are things we need to ensure. So first I'm going to install EKCTL. See, it's actually installed. This is a version. Now I am going to install kubectl, another command line tool for managing Kubernetes. Install. See the version. This is the version for EKCTL and this is the version for kubectl. Both are command line tool to interact. EKCTL is a command line tool for interacting AWS accounts. Okay. So for example, how we manage AWS account without this graphical way. Now we log in AWS account like open browser and type AWS console, then give the username and password, then log into our account. So this will we landed this landing page, and we can like installing and configure whatever we need. So this is one way. And another way is we can manage all the things. These all services or installing virtual machine, configure machines, all the things we can done by command line. So by working command line, we need to install EKCTL. So now I am going to create EKCTL. AWS manage Kubernetes service. I'm going to create using command line. So I'm using the commands like this. So this is interacting with the EKCTL. Okay, that like command line tool, EKS command line tool. Then create what? Create a cluster. Then we need to provide the name. So I am providing name test EKS. We can give on any name. Okay, like my EKS. Then the
Where
region.
do you
We need to
find these
specify.
command lines, Tawfiq?
Sorry,
Where do you find these command lines in online?
I didn't get you. Once again.
No, these commands, where do you find it in online?
No, not in online. These are in my notepad. So I use the same commands.
Okay.
So now I am explaining. We already installed EKCTL, right? So first we need to use the EKCTL command line tool, that is EKCTL. Using EKCTL, we are going to create a Kubernetes cluster. That is, we mentioned again, like create, then cluster. We are going to create a cluster. So these first three things are common, okay? Not three, that's four also, like name, dash name. We need to provide a name. So this will customizable, like we can provide any name. Then we need to mention the region, dash region. So which region we need to deploy in this EKCTL. I am using the same region, like US East 1. I am in the US East 1. So I am providing the US East 1. Then we need to provide the node group. So node group is when we configuring EKCTL graphical way, we can see the node group. Node group is nothing. It's a group. That group contains our working nodes. Okay, like how many nodes we have, then all nodes are inside our node group. So we need to provide the node group name. So our node group name here is my node. See, my node is our node group name. Then we need to provide the node type. Node type means the virtual machine configuration, like specification. Here we can choose T3 smart. So that is the specification of our working node. Then it's managed. See, dash manage. And the node count is equal to 2. Here we can change to 2 to 3 or 4, like so we can after deploying EKS, we can see our running nodes. Now it's only 2. I will change to 3. Okay. So hit enter. So here one more thing we need to configure, like this machine doesn't have the permission to create EKS. So what we will need to do, like we need to create a role and attach to this machine. Got it. This is coming to IAM. So here this is the IAM dashboard, okay, identity and access management. So here we need to provide, I mean, creating users, groups, policies, all the things we are done here. Like so in this case, we need to create a role. Create role. I think I have one role. I will check that. Yes, this is my role. I already created one role. Okay. So I will show you what are things inside my role. So I mean, after creating one role from scratch, I will add some permissions. Okay. What are the permission I include in this role? This, administrator access, then EKS, Amazon EKS cluster policy, and Amazon EKS worker node policy. So these three policies I attach to this role. The role name is EKS admin. So I already created a role. So what will we need? What will we do means just to go to the EC2 console again. And we need to attach the EKS admin role to the specific machine. In our case, the local machine. Okay. So click on that. Select the machine. Action. Security. Modify IAM role. And drop down. Here we can see the EKS admin C, EKS admin, and update IAM role. So we can say this machine have necessary permission to perform this activity like creation of Kubernetes cluster. So I'm just do the same command again. See, now it's working. It will take some time, like 10 to 20 minutes will take to create the EKS. So meantime, I will show you the HBA process. Okay. So after completion of Kubernetes cluster, we will deploy one application. We will deploy one application. This will be a sample application. Deploy a sample. And this application have the replica set like 2 or 3 or like that. So our requirement is this is our first node and this is second node. Okay. Sorry, this is a pod 1 and pod 2. This is the pod and this is the container. application. See. So our requirement is CPU. Okay, consider we can take CPU. CPU utilization. So the requirement is whenever we will hit our required CPU utilization, for example, it will calculate it by 0 to 100, right? 0 to 100 CPU utilization. So we can set the CPU utilization like if the CPU utilization is above 50, okay, above 50 or 60, what will we need? We need to create a one more pod, or we can set the pod count, okay. As per our requirement, we can set. So in this case, our desired state is 2, okay. So it will maintain the desired state. And we will provide like this, whenever the CPU utilization is above 50% or the required state, then we need to create more port, like to create 3 ports additionally. Like, so whenever hitting above 50, the Kubernetes knows that thing and the Kubernetes create what I mean our state, okay, like required state. So it will automatically create another port, and again 3 ports will create it because we set to the configuration hit above. I mean, whenever hitting 50% CPU, then create 3 additional port or 4 port like that. So it will create same instance of application like pod with the container. And whenever this hitting, I mean, this will decrease, like again, it goes back like 40, 30 like that. Then remove the created one and come back to the desired state, that is 2. This mechanism is called horizontal scaling. Horizontal. All of you know horizontal and vertical scaling mechanism, right? Horizontal scaling means create another instance of our application. For example, if we have one machine, okay, not, I mean, remove, I mean, not in Kubernetes place, okay. Consider we have 2 virtual machine. This is one virtual machine. This is another. This is a machine, okay, VM. 2 VM we have, and we deploy some application here. So coming to horizontal auto scaling, what will happen here? It will create another instance of virtual machine. And what are things inside the virtual machine? Like, for example, the machine have like a web server, then an application. All the things will created in newly created instance. So this is horizontal scaling we use in all scenarios, like virtual machine scenario, container scenario, all the scenario. Then for vertical scaling, this is another one, vertical scaling. Vertical scaling is all, it will not creating another instance of machine. It will create, I mean, we need to stop the machine. For example, we have one machine, okay. This is our virtual machine. So this machine have some resources like 2 GB RAM, then 2 virtual CPU like that. So coming to vertical scaling, what increasing in this virtual machine means the resources, only the resources. So what will we need? We need to stop the machine. Then we need to upgrade the machine configuration, like RAM 2 GB RAM now. Then we need to upgrade to 2 to 4 like that, or 2 to 8 as per the requirement. Same way CPU, we need to add the resource. Then we will restart the machine. So this is vertical scaling. So coming to vertical scaling, we need to stop the machine. So there is downtime. And coming to horizontal, there is non downtime because we recreating same machine with the configuration as per our required count. So same thing coming to Kubernetes, the name is horizontal pod autoscaler. Same thing happen here, like as per the requirement. Requirement means this is the critical, like our triggering path, like the count, CPU count or memory count or any other customized count, like specific application or whatever we need to configure that thing. Then as per the configuration, the autoscale happen within our worker part, Kubernetes worker part. Create another pod and container. Anyone have any doubt?
Yes, Tawfiq. Actually, I just want to know this scaling parameters. The DevOps engineer should know, or is the architect, AWS architect level, people should know this information?
There is a requirement. I mean, we will get the requirement from a higher authority like architect or lead or manager. Then sometimes we need to do the like case study, like anything like that, because this scenario is, for example, this is our application. Okay, we deployed to application, but like which scenario the CPU utilization, there are different scenarios there. Like sometimes some applications access more CPU. That's one case. And
Yes.
another case is we have lot of traffic. Like sometimes traffic hike is high. Like morning there is less. I mean, 0 to 10 or 0 to 1,000 traffic. I mean, people accessing our application. So evening or night, there's spike. I mean, again we face more spike. I mean, traffic spike. Like about 10K traffic we hitting night time or like that. So again, I mean, our pod will hang, right? I mean, more CPU utilization there.
Correct.
So different scenarios there. So as per the scenario, we need to do the auto scaling.
Okay.
Our cluster is still under post creation.
Tawfiq, is it possible to send some interview questions as of today? What all you completed? So if you send some interview question, based on that, list, we can read and practice along with that interview questions and get ready for that.
Sure. I will sort out some questions and I will update you, or I will
Yeah.
speak with you.
Okay.
Based on Kubernetes or total.
Total till now, till whatever 29 classes was over. So if you send interview questions for that,
Sure.
at least for every day 15 minutes, let's discuss about that five questions.
Okay, sure.
Okay, thank you.
Good suggestion to slow and steady wins the race. Five questions every day will build up a lot of questions over time.
Yeah. Thanks.
They teach us that story of the tortoise and the hare in kindergarten for a reason. You start slow but keep steady.
We have another. I just had a word with Tawfiq Kamul before you guys joining the class today. He told that another 15 classes is pending. So we have at least another 20-25 days left. So if you at least five question in a day, if you concentrate and work on that one, discuss each other, so at least 80% we can cover, I guess.
Yes.
Correct me if I'm wrong.
I think I'm going to attend the next class again after this one because there've been some small projects I got which I've been working on, and then I just need to practice and digest this more.
Oh, you already got the project?
No, but their projects are not related to this. There are other projects like.
Oh, you got it from Guru School?
No, like just locally here, like um, building projects and stuff like that.
Okay.
In other engineering projects,
Okay.
non-software, non-IT.
Okay. Okay. Tawfiq, actually, no. I was discussing with you regarding some contract job. You told that you're going to check with your the old students who got the contract job, and you mentioned that that's little easy to get it instead of going full time searching, and it will take time. Please,
Yes,
can you help us?
yes. I will. I think I missed that thing with the discuss with the previous students. I will check that. Yeah. Just
Please,
inform
Tawfiq.
after lab, just ping me if I forgot.
Okay. Yeah, I'll ping you that one
Sure.
because sitting home idle, it's getting bored.
Mm-hmm.
Because when I was in India, I used to go to office every day.
Sorry.
Okay. When I was in India, I used to go to office and work without any break continuously. All of a sudden, if I stop working,
Uh-huh.
daily it will be a hectic job, sitting idle at home.
Mm-hmm. You just ping me, okay, after the section, or yeah, I will update you.
So,
So
yeah.
see, now our cluster is ready. So you will get the last confirmation like EK cluster, my EKS is ready. So we can check using kubectl command. That's why we install the kubectl command before configuring the, before installing EKS get node. See, we created a Kubernetes cluster with the 3 nodes. So these are our 3 working nodes. T3 nano, right? Sorry, T3 small machines. And this is the version, Kubernetes version 1.3.0, 1.030. That's the latest version of Kubernetes. And these are the namespace. This will be our default namespace. And these are the namespace with that for our master part.
Tawfiq, what is the difference between the last class which we worked on Kubernetes and uh, self deployment and this class?
Both are different classes. That's for deployment strategy. So we used one deployment strategy, blue green, and we apply the blue green strategy within Kubernetes
Correct.
cluster. And
Okay.
this is entirely different. This is auto scaling. Kubernetes
Right.
HPA, actually, Kubernetes pod autoscaler. So this class for, how to scale up our resources or how to scale up our running pods within Kubernetes cluster.
Okay. In the previous class, we created some configuration file and app file to create the pod, correct?
Previously we created, the lab is,
Service dot
no, not
YAML.
this manager Kubernetes. This is manager Kubernetes. And previous class,
Okay.
we configure a Kubernetes that is self-hosted Kubernetes.
Okay. Oh,
Both
there
are
are two
different.
ways. Yeah,
Yes.
there are two types, right? One is manager and one self.
Yes, this Kubernetes managed by Amazon, and the previous class Kubernetes managed by us.
Okay. Okay.
And there are no pods in the default namespace as well. So now we are going to deploy. I mean, now we are jumping in our topic, like uh, like uh, we just deploy one sample application to our Kubernetes cluster. Then we will create one more resources. I mean, create one YAML file, that YAML file for the resource, horizontal port scaling, and we integrate that configuration with our deployment YAML. Then we will check. I mean, we will manually pushing some load to our Kubernetes cluster, and it will like increase the CPU count above 50 or whatever we provide in the YAML file. Then it will create the like another ports. Okay. So that we need the configuration file. I will check my configuration. YAML. So this is my GitHub repository. So I am just cloning these files from this repository, okay, to my local machine.
You're not scaling your, I mean, not showing other system, other screen, I guess.
Now you can see my, oh, sorry.
Notepad, yes.
Okay. So this is my GitHub page, okay. I'm just cloning this repository to my local machine. I will share the repository to you when you are done this lab. Okay, I will post the lab details in group. So before that, I'm going to create a directory HPA CD HPA. There's nothing here. So using git clone, we can clone the repository. Okay. So git command not found. So what we will do, we need to install git. Yum install git. Run the command again. Now it's download. See, Kubernetes manifest file comes here. So I'm going inside. Here we can see different files there. So I'm going to this file, HPA CD 05 HPA. Okay, fine. So in this directory, we can see 3 files. One is our deployment app. This is
Have you lost your voice, Tofik, or you just do working?
sorry. I'm on. Hello. I'm audible, right?
Yes, you're audible.
I'm all. You hear me? Okay. So we have three files. One is deployment YAML. Then one is for the service YAML for this deployment. Then we need to create one more file called hpa.yaml, or we can name it any name. Okay. So this is our horizontal pod scaling YAML. So we need to create that thing. I will explain the HPA. Okay. So before that, I will deploying this symbol YAML deployment YAML. So cat see, this is the symbol YAML file. This is a deployment. Kind is equal to deployment. Then the metadata name HPA demo deployment. Then Yes, again same. And the replica is 1. Okay, see, only one pod will created with one container. Then template metadata label same HPA deployment. Then the container name, same HPA demo deployment. Then we need to provide the image name. So this is the image name. This is a sample image name from kubernetes.dcr.io HPA example. Then for this application, we need to provide the port number, container port number, that is 80. And here we can see new things like resources. Two type of resources under here you can see. One is limit and one is request. For this, I will like will explain in another class. Okay, so it's another topic.
Can you modify the replicas and see?
Yes, we can modify. Same, we
Because
can
let that increase the pods.
we can 1 to 2 like nano. We can do after deploying this, that we can see the main port count will increase like that. Okay, first I'm going to deploy kubectl, apply, then the file name, paste, hit enter. See, it will create it. You can check kubectl get pod. See, one pod. Actually, this is creating, actually container creating. It will take some time, I think. See, now it's running. Both are created. This container is up and running. That is, before it's not created the container. See, 0, 1 by the status is container under creation. Now 1 by 1. That means the container within the pod, the container is running 1 by 1. Got it. Now we are going to manually scaling. Okay. 1 to 2. Save and exit. We need to apply again. See, here we can see configured. Checking once again. See, next container under creation. So both 1 by 1 is done. Now we are going to apply our service. So this is a simple service file. This is optional. So because our requirement is to see how the auto scaling works. Okay. We didn't check the service. I mean, checking the application or anything. I'm just applying. Service is created. We can check all the things like under the deployment, we can check uh, our running pod services, all the things under the deployment, we can use kubectl get deployment instead of pod or service deployment. Okay. So here we can see 2 ports are there. Then this is our service. All are fine. Now we are going to apply our HPA. Okay. So I will show you. So this is our resource, and this resource for Autoscaler, okay, or Sondral Pod Autoscaler. So here we can see the app version, scaling v1, then the kind. This is the main thing, okay, the kind. This kind name is horizontal pod autoscaler. So Kubernetes, this is actually a kind in Kubernetes. So Kubernetes, no, this is for autoscaling. And the metadata, here we can see the metadata, and with metadata we give the same name, HPA demo deployment. And how this this resource is integrating with our application, because coming to Kubernetes there is a lot of other applications, right? So here we can see the spec, under the spec, scale target reference. See, so under the scale target reference we provide the application name. I mean, which application that we need to scale our resources, like scaling the pod. So all the things we provided uh, under scale target reference. So here we provide the application version 1 and the deployment kind is equal to deployment and the name of the deployment, that is HPA demo deployment. So these 3 things are the details of our deployment. Here, this deployment file. See, version 1 and the kind is equal to deployment and the name is HBA demo deployment. So this autoscaler, no, I mean this autoscaler, after deploying this autoscaler, it will monitoring that application, that specified application we specified here. And it will monitoring what? See, the target CPU percentage is equal to 50. So this autoscaler is continuously monitoring that machine's resources. Whenever it above, I mean this percentage 50, it goes to above 50, then that machine will create this maximum replicas and minimum replicas. So the minimum replicas is 1 and the maximum replicas is 10. It will create 10 more instances of our application. That means 10 more pod. When hitting, the CPU percentage is 50. Got it. So we are going to apply our YAML file. So before that, I am just go back to the desired state. Anyone have any doubt? I'm all okay.
No, I think I'll have to. I started the meeting with my phone, and then I finally got on my laptop, so I missed a little bit. But I think I don't know how much everybody else has digested this, but I have not digested this.
This is nothing actually, just auto scaling our resources within Kubernetes cluster using HBA resource configuration. So now we are going to deploy that resources. Okay, I mean the YAML file.
I'll
ls
just watch the video again, I guess.
kubectl apply. Now I am going to apply. Okay, apply file name 0 3 underscore HPA. .yaml. See the horizontal pod autoscaler created. And one more thing we need to install when coming to this lab, because for this Kubernetes, okay, inside Kubernetes cluster, we need to monitor our resources like our memory utilization, CPU utilization, all the things we need to check using our kubectl command, okay, like kubectl top node. Top node command we use for checking the utilization, right? So here you can see here are metrics API not available. So we need to install the metrics within our Kubernetes cluster so that we can see our utilization, all the things within our Kubernetes cluster. So this is my local machine, okay? Like my local machine, we can check like just top, we can see the memory utilization and CPU utilization, all the things like this. So coming to Kubernetes, we need to install the metrics as well, okay, to checking our Kubernetes resources utilization. So I'm just going to install that metric server, okay, inside our Kubernetes. So that is kubectl. I'm audible, right?
Yes, you're audible.
Yes.
Okay. So for installing metrics, we are using a instead of like we didn't have any YAML file, so we can use from GitHub. Okay, so apply file name here. File name we can specify the.
Your voice is breaking now.
Now it's stable, right?
Taufik, you're not audible now. Hello.
Oh, give me a second. Give me a second. Now it's stable, right?
And now it is fine.
Okay. Okay, I'm audible, right?
Yes, you're audible.
Yes.
Yes.
Okay. So now I installed that metric server. Okay. You can see kubectl apply. Then we didn't have the file, so we can directly hold the file from official GitHub page. Okay. So this is the path for the file. So this is in that some files in github.com and the directory Kubernetes signs, then another folder inside the Kubernetes sign metric server, then another folder inside the metric server, that is release, then another folder latest, then coming to download. This is the file name actually, components.yaml. So this calling, I mean, this command will go to the corresponding directory and take the component.yaml file. So what are the things inside the YAML file? So that will created here. See, it already created. Got it. Now we can check with the kubectl top node. Sorry. See, we can see our running nodes. Three machines. Yes, three nodes are in our Kubernetes cluster. These are the three machines and CPU core, the minutes and how many CPUs are utilizing for each node and the memory, all things we can see using the top node. Top board. So coming to top board, we can see only one deployment there. So see the memory core and CPU core and memory. Then now we are successfully installed kube like metric server. Okay. So this is our HPA deployment actually. Okay, I mean, this file, after we deploying our hpa.yaml, so this is our HPA configuration. I mean, details we see in our configurations we can see in Kubernetes. Using kubectl get HPA, it will show us the corresponding HPA. So name is HPA deployment. Just for your information, in our case, HPA deployment, here we can see then the reference deployment, HPA deployment. This reference means the target reference. Okay, so this HPA is related to this deployment. In our case, only one application deployment there. There are sample applications. So this is a deployment case. Then CPU target. Here we can see the CPU's target. As of now, the CPU's target is 0 because this is a small application or there is no traffic. So only 0 and our target is 50. See, so whenever this 0 goes above 50, what will happen? Minimum board 1 and the maximum board 10. So it will create ports, like how many ports we associate here, the maximum port 10. So we can see 10 ports will create there. And now everything is fine. We can, like in our case, we deploy our application and services. Then we use pod autoscaler for our application. So how to check? We can check with one's application. That application automatically generated more traffic to our running pod. Okay, so we can check with that. So this is the command. Well, Meanwhile, I'm just duplicate one more tab, okay? So we can see the. Okay, as of now, 0, okay? Now I am going to automatically manual pushing the load. So this is a command to run. This is actually a load generator, okay? Using a image called busybox. So just run. So here I am again checking. See, as of now, 0, nothing happened. kubectl get pod. This is leave this one, okay? This is the load generator actually. It will create another port. So from that port, it will generate that load to our running ports. See, now the count is 216. You changes, you can see the changes, right? Now we can check the port. See, already created 2 ports and one is under creation. Again, it will hit to 10 actually. That's our desired state. Yeah, whenever hitting 15, it will create 10 port. 1, 2, 3, 4, 5 as of now. So it comes down. That's why it doesn't create another thing. We need to some cooldown time for back to 50. Okay, I just terminated the port that is generating load. So we need to give some cooldown time, okay, to back to normal state. Coming to the desired state. In our case, our desired state is port 1, right? That we specified in the YAML file. Yeah, now the CPU counts back to normally 0. Here we can see the replica 6. So anyone have any doubt regarding all of you?
I don't know how much everybody else digested this, but maybe this one, maybe you have to
Yeah, even actually,
teach again.
I'm having some confusion on this one. I have to bifurcation myself that managed server, kubectl, Kubernetes, and self-deployment Kubernetes, and deployment strategies. And many things I had to bifurcation. I have to learn this one.
Mm-hmm.
You know, I'm the other person who's studying slowly. Because I think Kubernetes, it's a little big subject, I guess. In
Right.
the DevOps.
Yes. This is one of core topics actually. Kubernetes, Docker, Jenkins.
Okay.
Amol and Tejaswini all are okay. Now
I mean, do you
you
think we should do this portion again, repeat this a little bit, study it again with him, or
sorry.
does everybody feel that way? We should do this lecture again.
Yeah, I'm okay to repeat this one.
Is it possible, Tawfiq sir? We didn't really digest this lecture that much.
Yes. First go through the record section. Okay. If we didn't get anything,
Okay.
then we can do one more lab. No problem.
Oh, okay.
Because this
Thank you
is
so much.
simple one actually. Because I think we done the auto scaling in virtual machine state, right? I mean scenario. We didn't do that lab, right? I mean auto scaling. Amol.
Yeah, that lab we did, right? The auto scaling. This is we manually scaled it horizontally.
Okay.
Yes, both auto. HPA is auto, and manually also we changed the replicas when we did it today.
Okay.
Correct, but it's getting little confusion for me in terms of command and everything.
I will give the same task. Okay. So whenever you all get free time, just to try to do the lab. Okay. Like creation of EKS, the way I did, then clone the repository, then try to install the application and also report auto scale. Okay. That would be fine, right?
Okay.
Just try to finish the lab. Then we can wind up today's section, right? All of you.
Sure.
Yeah.
Yes.
Have a good night.
Yeah.
Thank you.
Bye.
Good
Bye
morning
all.
and good night to all.
Bye.
Good morning, Tawfiq sir. Bye.
Yeah. Bye.